Good evening one and all. Today we are going to see lecture number 21, and this lecture number 21 is about energy storage and regeneration and regenerative braking. Initial part of the regenerative braking we have seen in the previous lecture, that is lecture number 20. We have seen the basics of regenerative braking, and here mainly we are going to see regenerative braking, and with that we are going to see there are two types of braking mechanisms, hybrid braking mechanisms and all that we are going to see in this session, and towards the end we are going to see battery management system. So this lecture is going to be more than 1 hour. So what topics we are going to see here in this lecture is given in this slide. So fundamentals of regenerative braking in the book of Ehsani, which is our textbook, you will find it in module number 4, and then we are going to switch to battery management system, for which we are going to follow PDF, and that PDF will be sent in your lecture in Google Classroom. The same PPT will be uploaded, and this lecture link also is uploaded there. So brake system of EV, HEV, FCV. HEV is the hybrid electric vehicle, FCV is the fuel cell based vehicle. This slide actually you have seen towards the end of the previous lecture. So regenerative braking in these three systems, EV, HEV and FCV, introduce a slight complexity of the braking system design. Two basic equation arises, or two basic questions are there. Number one is how to distribute the total required braking forces among regenerative braking and frictional braking. So regenerative braking is actually called as electrical braking, frictional braking is actually called as mechanical braking. So whatever is the braking force required to be generated for brake to stop the car, how much of that should be mechanical, how much of that should be electrical, this has to be decided, or this has to be calculated very fast by the ECU or electric control unit, and accordingly the mechanical brake, which is friction based, and electrical brake has to be generated. So this is the first question. Among the brake force, how much should be electrical, how much should be mechanical? And we know that in the second question, how to distribute the total braking force on the front and rear axle. So there are front two tires, there are two back tires. Generally we call it front axle, back axle. So one thing very important is there, that is all the four wheels should get brake force at the same time. All the four wheels should stop at the same time after applying the braking force. If there is a mismatch of this timing of the application of brake force, then there is a chance that the vehicle might topple, or vehicle might go turtle, or it will matlab gaadi ulta ho jati hai. So all the brake force should be applied together, that is one thing. But how much brake force should be applied in the front axle to the front wheels, how much brake force should be applied to the rear wheels, this is also another question. So all these things are actually following a certain algorithm, and ECU decides how much brake force should be generated at the front wheel, how much should be generated at the back wheel. Generally we have seen passenger cars, initial front wheels are actually disc type of wheel, and back wheels are actually having drum type of brake. So front wheels are having disc type of brake, back wheels are having drum type of brake. Usually regenerative braking is effective only for the drive axle, that is the front wheel of the passenger cars. In the back side we don't have regenerative braking. Electric motor must be controlled to produce the proper amount of braking force to recover as much braking energy as possible. Now this is the conclusion which we had seen in the previous class. It is saying that braking force must be sufficient to meet the vehicle deceleration commanded by the driver. So whatever distance within which driver want to stop his vehicle, depending on the driver pushes the brake pedal, and accordingly the vehicle stops within a very short distance, or within a very short duration. So how much brake force is applied by the driver, depending on that the vehicle should stop. So we should see that there should not be any accident, because brake is mainly a safety device. There are two configurations. We are going to see these two configurations in details in this lecture. That's why this is the regenerative braking. So two configurations of hybrid brake system. So what is meant by hybrid brake? It is the combination of electrical braking as well as mechanical braking. So two configurations of hybrid brake systems are discussed next with their corresponding design and control principle. So all these are generally hydraulic type of brake, whenever it is called as mechanical. So one type is parallel hybrid brake system. So this question can be asked in the exam for 10 marks. You have to draw the block diagram, you have to explain each and every part of it. So first type of brake system is parallel hybrid brake system, which has a simple structure and control and returns all the major components of conventional braking. And the other part is fully controllable hybrid brake system. So parallel hybrid brake system and fully controllable hybrid brake system, these two are the two major things we are going to see in this lecture under the heading of regenerative braking. So this fully controlled hybrid brake system, it can fully control the braking force for individual wheels. Actually there is something called as a in-wheel drive. In-wheel drive means you are actually generating the traction force at every wheel. So whenever I am saying fully controllable hybrid brake system, this is also kind of a in-wheel brake system. So it greatly enhances the vehicle braking performance on the all types of roads. Okay, this is the first type. This is the parallel hybrid brake system. You are finding what are the components of the brake system towards the right. So while you are showing this thing in the exam, not necessarily to draw this kind of cylinder or master cylinder booster, you can draw represented by a block diagram. So this is the brake pedal, first thing, and this is the position sensor. So how much press driver is doing to the brake pedal, that is actually picked up by this position sensor. So too much shift in position of this brake pedal means the driver has pressed the brake to a greater extent. That means this whole system has to generate a huge amount of brake force. So this is the master cylinder. Inside this cylinder there is very viscous fluid that is actually called as a brake fluid. As soon as this is pressed, this pedal is pressed, this brake fluids actually flows through these channels and it comes to the caliper, which is there in the front wheel and which is there in the rear wheel, and they actually generates the motion, or they generate the force, which actually is actually allowing this caliper to apply force on this disc. Okay, so this is generally the configuration of brake. That is, as soon as this thing is pressed, a liquid actually flows through this. Liquid actually flows from this master cylinder through these lines. There are a lot of other controls there. There is a pressure sensor. This pressure sensor actually ensures that inside this fluid line, that is brake fluid line, the sufficient amount of pressure is maintained. Okay, and after that, through this fluid lines, this fluid goes to the caliper. Caliper is kind of a gripping mechanism which grips the disc which is connected to the tire. So as soon as this liquid goes inside the caliper, this caliper actually holds this disc. So more amount of brake force is required. There is actually mechanical braking. More amount of brake force required. At that time we have to press this brake harder, and more amount of fluid will pass through this, come to the caliper, and caliper will immediately stop the vehicle. One very important thing you can find out, that from the towards this line of the brake fluid, the distance for this side is longer, distance of this side is shorter, but the actuator and ABS controller, and ABS is actually anti-lock braking system. What is anti-lock braking system? Anti-lock braking system is a system which does not allow the vehicle to go upside down, okay, whenever the brake is applied. So many a times you might have seen that when a vehicle applies very hard brake, okay, that means within very small time the vehicle has to be stopped. So very hard brake is applied, that means brake pedal is actually pressed to the ground. At that time, due to sudden stop of the vehicle might go upside down. There is a possibility, okay, the whole chassis actually goes upside down. Anti-lock braking system prevents that. So this kind of question can be asked in the interview, that is, what is the job of anti-lock braking system. So you have to say that anti-lock braking system mainly does not allow the vehicle to go upside down when too hard brake is applied to the vehicle. Okay, so here you are finding vehicle controller. Vehicle controller means it is controlling the motion, it is controlling the acceleration, it is controlling the brake. So all type of controlling action is being controlled by this vehicle controller. So this is also a ECU, electrical control unit. There is a speed sensor. Here I have says about pressure sensor, which is sensing fluid pressure inside this brake line. Here is actually the brake position sensor. Here is speed sensor. This is the axle. Okay, there is a brake plate. Brake plate is actually held by this caliper. Caliper actually is getting the power transmission from the, or that is brake power transmission from the fluid. So each part you should know very clearly. Motor and controller, this is energy source, they are actually connected to the vehicle controller. So this motor is actually running the vehicle. I think to the right side, this is actually the front side, and this is the back side. Whatever it is, there are 4 wheels, and you are finding that this ABS controller is connected to all the 4 wheels. There is anti-lock braking system, and you are finding there are mainly 4 kinds of lines. One is a mechanical connection. So here you are finding there is a mechanical connection between motor and axle. There is a fluid connection. Fluid connection is actually in this braking, they are hydraulic brake, hence actually from this master cylinder and booster, which is actually storing the brake fluid, from there to all the 4 wheels there is the fluid connection. Then there is control signal. You are finding this ABS controller is receiving the control signal, vehicle controller is receiving the control signal, all these are there. And finally there is electrical signal. So electrical signal also you can find out from this energy to the vehicle controller. Then from here electrical controller, so here is a sensor which is actually vehicle speed sensor. This is giving signal to the ABS controller and all. So this is actually schematic structure of parallel hybrid brake system. Here this is called hybrid because here regenerative braking also you will be finding, though the components are not shown, but you can generate regenerative braking here. So this motor generator set is there, and the hydraulic part, that is mechanical part, is also there. So there is a simple system which is closest to the conventional pure mechanical brake, hydraulic or pneumatic. This system actually retains all the major components of conventional mechanical brake and adds electric braking directly on the front axle. So this is only the electrical only the mechanical part is shown here, though it is said that this is parallel hybrid, but actually only the mechanical part is shown here. With this, whenever we are adding those motors and battery and all those things, it becomes a hybrid thing. So ABS is anti-lock brake system. It consists of 3 things: wheel speed sensor provided by the individual wheel. So ABS, you can see that this ABS is having, anti-lock braking system is having output from various sensors. So wheel speed sensor, so you can find here towards this bottom there is a sensor. There is actually wheel speed sensor. There is also wheel speed sensor. They are giving input to the ABS controller. That means the controller is coming to know how much is the speed of each wheel. Depending on that, it will generate anti-lock braking signal. Second thing, this ABS anti-lock brake system is having ECU that obtains a slip ratio and calculates a signal that will adjust the slip ratio on the adequate value. So this is a vehicle controller. It decides how much brake to be generated, was the slip ratio, depending on that how much of ABS signal has to be generated. All those signals are calculated by ECU. This is a very smart microcontroller kind of a thing. Third thing is an actuator that sets the brake pressure based on the signals from the ECU. So as soon as ECU, that is a vehicle controller, gives the signal to the actuator actually is opening or closing these valves. Okay, so signal is generated by the ECU, but closing or opening of the valve is done by the actuator. So that actuator actually will be opening or closing this valves, and depending on that the fluid will come, and whatever caliper you are finding, brake caliper, this is also an actuator. So this is a mechanically controlled actuator, where this, or hydraulically controlled actuator you can say. Hydraulic pressure is coming, the brake caliper is getting shrunk, and it is holding the disc, and it will generate a brake force. So actuator that sets the brake pressure based on signals from the ECU. So brake pressure is actually depending on the shrinking of this brake caliper or holding of this brake caliper. So more forcefully it is holding this disc, more brake force will be produced at the disc. Last one is pump in ABS unit, is used to restore the loss in pressure due to the hydraulic brakes after the hydraulic valves have released it. So there are different valves. There is a big master cylinder, and there are different valves which are actually maintaining the pressure in the hydraulic brake line. More knowledge about this parallel hybrid brake system. There is a mechanical brake system consists of a master cylinder or booster, this one. It may or may not have a ABS controller. So ABS controller is actually there in the high end vehicles, but nowadays almost in all the vehicles ABS controllers are there. This book was written long back. At that time ABS was a fascination, but now ABS is a necessity. So it may or may not have ABS controller. You should not write that. You always should write the vehicle must have a ABS controller. An actuator, but has a brake caliper and brake discs. Okay, electric motor directly applies its braking torque to the front axle and is controlled by a vehicle controller based on vehicle speed and brake pedal position signals. Signals represent the desired braking strength and braking control strategy embedded in the vehicle controller. So how much is the speed of the vehicle, how much is the slip, what is the condition of the road, depending on that continuously there is a brake algorithm which is being run inside the vehicle controller. So as soon as it gets the input from the tires, how much is the speed, it knows about the slip. Depending on that, ECU generates a desired signal, and that desired signal actually opens or closes this fluid lines which are actually connected between the master cylinder and booster and the caliper, and accordingly the fluid goes, or fluid of certain pressure goes into the caliper, and the caliper holds the disc and brake is applied. So parallel hybrid brake system, you are finding the same thing, same block diagram is shown here. The feature of the parallel hybrid brake system is only the electric braking force or torque is electronically controlled. Mechanical braking force is controlled by the driver through the brake pedal before the ABS starts its function. So whatever mechanical system is there, this is actually producing the mechanical braking, and electrical braking is actually, that system is not shown here, but you can find here only the electric braking force is electronically controlled. So there is a motor, there is a motor controller and all those things, those are actually ensuring the electrical braking. So what is meant by electrical braking? Electrical braking is nothing but adjusting the current to the main motor who is driving the wheels. That is the mainly electric braking and control of electric braking. So how much current is to be given to that main motor who is driving the wheels, that is actually controlled by the electronic controller of brake force. Mechanical braking force is controlled by the ABS when the wheels are about to be locked. Okay, as in conventional brake system, the key problem in this design of control system is to properly control the electric braking force to recover as much as braking energy as possible. So mainly whenever you are explaining this diagram, you have to mainly explain the mechanical part of it. Every part of the mechanical system, like this vehicle controller, what is that, ABS controller, motor controller. So this motor controller is actually controlling the brake force, energy source, brake caliper, brake pedal, axle, so front axle, rear axle, both are there. Okay, this cylinder, this brake pedal, all this thing you have to explain in detail actually in this parallel hybrid brake system. Next is, it is called as a fully controlled hybrid brake system. So this will not be asked in the exam, but just for your knowledge sake you can prepare this. So in recent years, more advanced braking systems have emerged that allow one to control the braking force on each wheel independently. So previously you were finding that each wheel was not given each wheel was not having independent controlling unit, but in the next type of system, which is called as a fully controlled hybrid brake system, you will be finding that there is controller for every wheel separately. So you will be finding that what are the things. So there is a master cylinder. This cylinder is full of brake fluids, and depending on requirement it generates the pressurized hydraulic fluid through these lines, and these lines are connected to wheel. Second thing is, you are finding brake pedal position sensor, brake pedal pressure sensor, speed sensor, brake plate, brake caliper, all those things are same. This is something called as a 3-port switch, and electrically powered brake actuator, motor drive and transmission. So one new thing you are finding here is fluid accumulator, and they are actually connected to each fluid separate, each wheel separately. That means each wheel here can be controlled separately. So that is the main thing in fully controlled. So what is meant by fully controlled is every wheel is given separate control for braking, and some higher end controllers are being used. It is called as HEBS and ERB controller. They are actually higher end controllers. So in recent years, more advanced braking system has emerged that allow one to control the braking force on each wheel independently. That means it is possible that one will be given a braking force and one will might stop suddenly. Hydraulic electric brake system, which is called as HEBS, and mechanical brake systems are two typical examples. Fully controlled hybrid brake system consists of a hydraulic electric brake and a electric regenerative brake. Okay, so that's why this is called as hybrid, because here hydraulic brake is also there, electric brake is also there. Mechanical brake system consists manually a brake pedal and its position sensor, a master cylinder, electrically operated and controlled brake actuator, electrically controlled 3-port switches, fluid accumulator, pressure sensor and all. So these are little different components here in this case. What are they? That is this electrically operated and controlled brake actuator, electrical controlled 3-port switches. So these 3-port switches are very important. You are finding, as there are 4 wheels, there are 3-port switches. These are actually controlling the direction of fluid from the cylinder to the wheel or to the caliper. Okay, because wheel friction is generated by the caliper. So it is possible to control the friction at each wheel separately. That's why these 3-port switches, fluid accumulator, they are the new thing in this fully controlled hybrid brake system, which was not there in case of previous hybrid braking system. So what it's saying is the torque command to each wheel is generated by the HEBS based on the pressure signals from the pressure sensor, brake pedal stroke signal, and wheel speed signal by the speed sensor, embedded control rule, HEBS controller. The whole braking system is controlled. The mechanical braking torque applied on each wheel is independently produced by the corresponding brake actuator, which is commanded by the HEBS controller. So main thing in this fully controlled hybrid brake system, though it will not be asked in the exam, you should know that these are the 4 jobs which are being done by this fully controlled hybrid brake system, and each wheel can be given a brake force separately. So brake fluid from master cylinder flows into the fluid accumulator. In this case, we will be finding a fluid accumulator, which is a special thing in this case, and through 3-port switches to exert pressure and emulate the braking feeling of a conventional brake system. In this case, the failure of any brake actuator, the corresponding 3-port switch to the mode port 1 and port 2 open and port 3 closes, so that the brake fluid from master cylinder goes directly into the brake caliper cylinder and thereby maintains the brake torque. So for more control, you don't have to go into depth. For more control, these 3 position switches are actually controlled by the electric control unit or ECU. This is actually the fully controlled brake system. Now regenerative braking main features. An electric regenerative brake mainly includes an electric motor and its controller and an onboard energy storage, so there is a battery. Electric regenerative brake controller is used to control electric braking based on the wheel speed, brake pedal stroke, charge condition in the energy storage, and control rules embedded in the controller. Second thing is, one of the key problem in this system, that is regenerative braking system, is the mechanical and electrical braking torques to obtain the acceptable braking performance, recover as much as of the available regenerative braking energy as possible. That means always there is a target that we have to achieve this much of regenerative braking. So continuously there should be a recovery mode. So the vehicle is continuously in a recovery mode. So that is a key problem in this system. How to control the mechanical and electrical braking, because I told you there are mainly 2 problems. First problem was whenever the braking force is generated, how to divide it among electrical braking and mechanical braking. So how much percentage should be electrical, how much percentage should be mechanical. That was one problem, and that problem still arises. It is saying that how to control the mechanical and electric braking torques to obtain the acceptable braking performance and recover as much as energy as possible. 2 typical control strategies introduced in this session. Number 1 is emphasizes the braking performance. Number 2 emphasizes the maximization of regenerative braking for energy recovery. So 2 things we have to ensure: the brake performance should be satisfactory, and within brake performance, maximum brake performance should be created by the electrical braking. Electrical braking actually gives regeneration, so we can recover more power. These are the links. Actually, we are, after this slide of regenerative braking, we are now going for battery management system. So battery management system, 2 links you have to follow. So this links of the second link, that is Dr. Gregory L. Plate, University of Colorado. Huge amount of material you will be finding in his site. So you just please follow this, that mocha-java UCCS edu BMS1. This site is still active. Today in 2023 only I have checked. So today itself, 31st May 2023, I have checked this site. This page you will be able to find. This is the first module, battery boot camp, equivalent circuit cell models, microscale cell models, okay, all those things, and chapter 2, 3, 4, 5. Okay, so chapter 2, 4, 6, ESC model, of toolbox, then Python port. So all the practical approaches related to battery modeling is done here. So this what I have actually downloaded their notes also, so that note we are going to discuss now immediately after this. So these are the two links you should follow while you are studying the battery management system. So now what we are going to see is from this site of Dr. George Gregory L. Plett, Dr. Gregory L. Plett, depending from this site, whatever PDF we have downloaded, that PDF we are going to discuss now about battery management system. So it is mainly a embedded based system, and it is mainly for maximization of battery performance. Maximization of battery performance means maximizing the output from it, increasing the efficiency, and maximizing the lifetime of the battery. So not always necessary that you should extract maximum energy from the battery, not necessary. Sometimes you should operate little bit less than the maximum efficiency. That will help you maximize the lifetime of the battery. So all those different strategies are there. There are recombination of cells and all. So it's around 30 to 33 page document. We are going to see around 6 to 8 topics from there. So next is it is called as a battery management system from the slides of Dr. Gregory L. Plett. So that will be another video. It will be uploaded immediately after this. Thank you.